This is our injection molder for Group C8, Molded Not Machine. The task of this project was to create a desktop-sized injection molder which operated without overly complex inputs and held to an overall budget of $240. More specifically, the objective was to design, manufacture, and build a relatively simple, inexpensive injection molder to reuse and repurpose plastics that are currently thrown away. The controller, in conjunction with the 3 heating bands which produced a total power input of over 400 watts, allowed for injection of multiple plastics as defined as an objective in our initial sprint report. This was achieved by plugging the system into a simple 120 volt AC wall outlet. The system was set to a temperature of 265 degrees Celsius for polypropylene plastic, approximately 100 degrees Celsius above its melting temperature. Here, our CAD model is shown. As you can see, we chose a plunging mechanism for the injection molder as that had scored highest in our design matrix. The maximum budget of $240 was achieved, with a total production cost of $190. The system weighs approximately 10 pounds, which again fell within the set constraint and was easy to carry around and adjust. Additionally, the set constraint of the system being desktop size was achieved, with the system being approximately 24 inches deep, 24 inches wide, and 36 inches tall. In this video, the mold for our design was CNC'd. This is the finished product. Held together by 4 bolts with a washer and wing nut, the plastic was injected through a threaded hole on the top. As the plastic heated up inside of the system, it would expand and bubble over the top. Preventing overflow required consistent monitoring and stirring of the plastic to get rid of the bubbles. This video shows the plastic being injected into the mold. The consistent flow of plastic out of the nozzle verifies another objective which was defined earlier in the process, which was to heat plastic with even consistency. Additionally, the ease of use was confirmed as the low viscosity of the plastic being injected allowed for ease of use when pressing the lever. The total injection time is less than 15 seconds. The mold was made of aluminum. The injection molder is capable of attaching to multiple molds as long as the total volume of the mold is less than 7.13 cubic inches. The final part, shown here, takes a total production time of approximately 10 minutes, which can be immediately repeated once the heaters are warm. This is the first injected part. Trial and error was then conducted to achieve a more full and precise injection. A second vent was added on the top of the mold to allow air to escape. This eliminated the issue of the part being hollow. This was the best part produced from the 5 trials. The main innovation which would further improve the quality of the final output would be adding a valve to the nozzle. As it stands, the mold must either be quickly attached once the plastic is running out of the bottom, or it must be attached earlier, which allows for overly viscous plastic to be injected, resulting in an uneven surface finish. If a valve was added, the mold could be screwed on before the system is plugged in, and the plastic held inside the barrel until sufficiently heated. Many of the specific predefined objectives were discussed throughout the duration of the video, but overall the system achieved our goal while keeping within the constraints that we had laid out. It stayed under budget, it produced parts in a reasonable time, it was easy to use, and the process was repeatable.